Let's talk about 1072. Flix columns for maximum number of equal rows. They give us a n multiple by n matrix, and this matrix has 0 or 1 in it. And we can flip any number of columns in the matrix. So flip is change 0 to 1 and change 1 to 0, and return the max number of rows after some kind of flips. So for example, 0, 1, 1, 1, right? We don't need to flip. So the maximal number is 1. And 0, 1, 1, 0, the max, if we flip one column, for example, flip to 1, 0, it will return 2, right? Because 0, 0 is the same, 1, 1 is the same. So let's look at the third example, 0, 0, 0, 0, 0, 1, 1, 1, 0, right? So what we do is that we flip the first two columns, right? And so it will be 1, 1, 1, right? And this will be 0, 0, 0. And this what does not match, so we will return 2, right? So actually, so what we're thinking about this question is that if we have uh, we already have this matrix, right? So we can look at, for example, 1, 0, 1, 0, 1, 1, 1, or those kind of string. If after they flip, right? If there is another one, 1, 0, 1, 1, 1, they will flip, have the same result. And if we have another string like 0, 1, 0, 1, 0, 0, 0, one flip, right? It will flip in the opposite position result. So what we do is that if we trying to look for the maximal counts of this kind of pattern, right? So how can we define this as a pattern? Of course, we can use some kind of string, right? Get this as a string, and let this two map to one string, right? But the thing is that we can use another way to define the pattern. So let's look at it from the second index, the index 1, right? If it doesn't equal to the first, then we use a different, right? Then this is different. This is different. This is different. Then this is as same, right? 1 equals as 1. This is same, right? So this is D S S. You see, this 0, 1 this is different, right? Different, different, different. And S same, 0, 0, this same, right? So you see, we just convert the row into this kind of string, right? Then use a map to find its counts and get the maximal counts of the maps. So we are looking for the highest counts of the patterns. That is our result. So let's write code for this. So what we do is that we're going to uh, have a map integer map, right? So this will have the count of the pattern, hash map, and for every row in matrix. Then what we do is that we need to convert this to the to the string, right? Use as a key as a pattern string. So what I do, string builder for int I equals 1, I smaller than row dot length uh, I plus plus. So what we do is that so we're going to have a string append append uh so that will be if row I equals row I minus one, right? Then we're going to append same, right? Otherwise we append difference. So the key will be the toString, right? Then we're going to have a map merge key or integer dot sum, right? And then we find the largest result from the values, find the largest count in map dot values. The result was max dot max. We result in the end return result. Magic key, convert to integer. Let's make this as string. And the Python code will be very similar. And we can have, for example, um, we can use actually we can just use a patterns list, right? And we let's have this as a length of matrix 0, and we can have a pattern as list. And we just want to find the most frequent patterns for this, right? For row in matrix. So what we do is that we're going to have a pattern of this, right? Then for I in range 1 to n, we're going to have a pattern append if D if row let's say S if row equals row I equals row I minus one else. Okay. And so what we do is that we have patterns append. Let's have this one to B string join pattern. So we can use also for Python, right? Just use a counter equals counter. You can also write dict patterns and return max counter for values. D if invalid syntax, there is a dot here. It will be linear ON time complexity in the ON space complexity.